Hello everyone, can you hear me? So it's been a long time since we last saw each other, and I hope everyone is doing well. And I believe that you will be starting school next week, next Monday, right? So that's pretty soon. So I hope everyone's doing well. And today's lesson will be on word problems on equations. So there are two main types of equations that we're going to be going through today. And the first type are linear equations that I wrote down. So what are linear equations? Linear equations are basically equations that have variables with a highest degree of 1. So basically what that means is that all of the variables in this equation does not have an exponent. So there will be like no variable with a square or a cube, then that is not it. So basically the Chinese version of linear equation is 一元一次 or like multiple 多元一次方程. So basically has something to do with variables. And linear equations are quite simple. And hopefully you were able to complete the preview questions, so I'll give you some time to finish the first one. Okay, so everyone got it correct. So congratulations, and this one is pretty simple. Basically what we have to do is just 3x will be equal to 12 and x equals to 4. That's why D is correct. And now let's move on to the next one. Again. I'll be collecting the answers, and congratulations, most were able to get the problem correct. The answer is E, 26. So I'll go through it really quickly. There are 90 guppies in 4 fish tanks in total. So there's one more guppy in the second tank than in the first tank. So let's say that there are X guppies in the first tank. Then there in the second tank, there will be X plus 1. And in the third tank, it will be X plus 1 plus 2. So in the fourth, it would be x plus 1 plus 2 plus 3, which is x plus 3 and x plus 6. So therefore, adding it all together, we have 4x plus 10 equals to 90, and x is equal to 20. So the fourth tank would have 20, x plus 6 equal 20 plus 6 equal 26. So that would be our answer. Are there any questions for the preview problems? If not, then let's move on to our first concept on linear equations. So firstly, our allocation problem. So no matter how we allocate the item, the total number will not be changed. So this is our first example problem. Let me isolate it. Starting with some gold coin and some empty treasure chest, I tried to put 9 gold coins in each treasure chest, but that left 2 treasure chests empty. So instead, I put 6 gold coins in each treasure chest, but then I had 3 gold coins left over. How many gold coins did I have? So basically, it seems a bit complicated, but let's first use the variables. Let's say that G is equal to the number of gold, and C is equal to the number of, wait, sorry, my network's not very good. So let's say, wait a second, my network disconnected. Let me reconnect it. Huh. Okay. So as I was saying, let's say that G represents the number of gold coins that we have, and C represents the number of chests. So by turning this problem into two equations, we know that if we put 9 gold coins into each treasure chest, then we would have 9 C gold coins in total. But then there would be 2 treasure chests empty, which is 18 gold. Well, that means that 90 minus 18 will equal to G. And it says that 6 gold coins in each treasure chest would lead to 3 gold coins being left over. So 6C plus 3 is also equal to G. Therefore, we know that these two equations are the same. And by solving it, we can do some subtracting. Let's say 9C minus 18 minus 60 minus 3 would be equal to 0. So 3C minus 21 would equal to 0, and C would be equal to 7. So therefore, there are 7 chests in total. But then the problem asks us how many gold coins we have, so we have to plug them into this equation. So 7 times 9 minus 18 would be 63 minus 18 equals 45. So therefore, the answer is C, 45. Any questions? If not, then let's move on to a practice problem. Gonna firstly hand out a sketchboard. So I'll be collecting the answer, and congratulations to everyone who got the problem correct. The answer is 45. So I'll briefly explain it. Using the logic that we use to solve the exploration problem, we need to first look at the problem. So it says that we distribute some books to a group of students, and if each student received 4 books, there would be 23 books left. So if we assume that there are X students in total, then this would mean that there are 4x plus 23 books. And it says that if each student gets 5 books, there would be a shortage of 22 books. So that means that there are also 5x minus 22 books. So therefore, these two equations are the same, and by solving it, we have x equal to 23 plus 22 equals 45. And that's the answer. Are there any questions? If not, then we can move on to our next concept. So this is another type of problem. In a mathematical contest with 10 problems, a student gains 5 points for a correct answer and loses 2 points for an incorrect answer. If Olivia answered every problem and her score was 29, how many correct answers did she have? So there are 10 problems in total, which means that the maximum points are 5 times 10 equals 50. So this is like maximum points. So Olivia answered every problem and her score was 29. So you might think that we just have to subtract 29 from 50 and divide it by 2, but we find out that 21 is actually not divisible by 2, which shows that that method is wrong. So let's say there are 10 problems, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we assume that she got every single thing right. So that would be 10 times 5 equals 50. But then she only got 29. So that means that each of these was a plus 5. All the way to plus 5. So if she got one problem wrong, we have to subtract 5 points and subtract the 2 points. We have to subtract the 5 points that we gave her credit for and subtract the 2 points that she got for an incorrect answer. So in total, there would be minus 7 points. Are there any questions about this? So therefore, we have 50 minus 29 equals 21. And though 21 would stand for the problem that she got wrong, and the problem that she got wrong would lead to her getting 7 points off per problem. So therefore, 21 divided by 7 equals 3, which means she got 3 problems incorrect. And there are 10 problems in total, so 10 minus 3 equals 7, and she had 7 correct answers. Any questions? If not, then we can do the next problem. So this one is a little bit different. It says that Patty had 20 coins consisting of nickels and dimes. So nickels are 5 cents and dimes are 10. So it says that if her nickels were dimes, then her dimes were nickels, which means that they switched how many nickels and dimes there were, she would have 70 cents more. How much are her coins worth? So this seemed like a little bit of a confusing wording, so I'll explain the problem first. So let's say that she had X amount of nickels and Y amount of dimes. So that would end up with a total being 5X plus 10Y. Okay. And if basically it says that if her nickels were diamonds, her dimes were nickels, which means that if she had Y nickels instead and X dimes instead, then she would have 5Y plus 10X. So it's basically saying that this 5Y plus 10X has 70 cents more than 5X plus 10Y. So now that we understand the question, we can start to try and solve it. So X and Y seem a little bit confusing, so I'll replace it with N and D. Let me first duplicate this. And bring it down. So let's say that she has n amount of nickels and she would have d amount of dimes. So there are 20 coins in total, which means that d would just be 20 minus n. So she has 5n plus 10d in total, and if we plug 20 minus n in, then we have 5n plus 10 times 20 minus n, which is 5n plus 200 minus 10n, which is 200 minus 15n. And if her nickels were her dimes were nickel, then it would end up being 10n plus 5d, which is 10n plus 5, 20 minus n, and that would be 100 minus 15n. Wait, sorry. That would be 100 that would be 100 plus 5n cents. So it's basically saying that 100 plus 5n equals 200 minus 15n plus 70. So therefore, 270 minus 15n is the same as 100 plus 5n. And 20n would be the same as 170. So therefore, 170 divided by 20 is, I believe, 8.5. So she would have n. And therefore, it asks how much are her coins worth. Wait, let me solve it real quick. Oh, wait. This is supposed to be 5n. Wait a second, sorry. So it's 200 minus 5n. And I'll resolve this real quick. So if it says that, basically we have that 100 plus 5n equals 200 minus 5n plus 70. So we have 270 minus 5n equal to 5n plus 100. And 10n would be equal to 170. So therefore, n is equal to 17. She has 17 nickels. So therefore, there are going to be 3 dimes, d equals 3. And by calculating this, we have 17 times 5 plus 10 times 3, which is 85 plus 30, and that would be 115. So she has 115 cents, which would be $1.15. Are there any questions? If not, then we can do our practice problem. What's the question?
I checked it.
Okay, I'll be getting the problems in now. Let me first switch my microphone. Okay. So congratulations, most of the people who answered were able to get it correct. So this is a problem, and it says that Camilla had twice as many blueberry jelly beans as cherry jelly beans. So as you can see, what I did here was that I substituted blueberry jelly bean as B and cherry as C. So originally they were B equals 2C. After eating 10 pieces of each kind, she now has 3 times as many blueberry jelly beans as cherry jelly beans. So basically, B minus 10 would be 3 times C minus 10. And by expanding that, we have B minus 10 equals 3C minus 30. And it also says that B equals 2C. So by substituting that, we have 2C minus 10 equals 3C minus 30. So 2C plus 20 equals 3C. And C would be equal to 20. So there were originally 20 cherry jelly beans. And it says that he had twice as many blueberry jelly beans as cherry jelly beans. So 20 times 2 equals 40. And that would be equal to B. So therefore, the answer is D, 40. There are no questions for this problem. Then let's move on to the next concept. So this is the main concept that we are going to be talking about today, which is on Diophantine equation. So on the document, it seems really complicated, but basically what Diophantine equations are is basically a linear equation, except you know less, so it's like more difficult. It's kind of like 不定方程式. So you have to use more of enumeration, 枚举, and like 凑数 to get your answer, instead of just being able to get the answer easily, like we did with the original linear equation. So the concept here looks kind of complicated, but I'll explain it in a different way later. So if you have this document, you can ignore this part. But before we move on, let's first learn about modulo. So I'm going to really just do it. Modulo is basically a way to express remainders. For example, 14 divided by 4 is 3, and it has a remainder of 2. So, in modular form, it can be written as 14 is congruent to 2 mod 4, which means that when divided by 4, it has a remainder of 2. And the same for 19 divided by 5. So 19 divided by 5 is 3, and it has a remainder of 4, which can be written as 19 is congruent to 4 mod 5, which means that when divided by 5, 19 has a remainder of 4. So therefore, if 51 divided by 7 is 7 with a remainder of 2, then we would have 51 is congruent to 2 mod 7. And 10, let's see. 10 divided by 4 is 2, remainder 2. So that would be 2. It's the remainder. And 15 plus 14, it can go into 29. It can go into what's mod 4. So actually, I'll send you a poll for this. But it's quite easy. About 10 more seconds. So 40 seconds is up, and I'll collect the answer. Congratulations to everyone who got it correct. So basically, 29 divided by 4 is 7, and it has a remainder of 1. So therefore, it's 1. Okay, so that is basically the concept of modular and just the notation. So how we are going to incorporate this remainder thing into our Diophantine equation, I'm going to talk about now. So I'm going to first isolate these problems, and we can start down. Okay, so for the first problem, it says 2x plus 3y equals 8. And we basically don't know anything about this. But firstly, using the features of even numbers, 2x is even. And with the proper notation, it means that 2x is congruent to 0 mod 2. So, and 8 is also even. So therefore, that means that 3y is also even. So therefore, 3y has to be divisible by 2, and because 3 is not divisible by 2, y has to be divisible by 2. So we can start with enumeration. Y is equal to 0. When y is equal to 0, then x will be equal to 4. However, if we go back to the original problem, it says that only positive integer solutions. So y cannot be 0. And the first number after 0 that is even is going to be 2. So y is equal to 2. And if that is true, then x will be equal to 1. And that's our solution. So the main point about Diophantine equations is to think about remainders and what the numbers are divisible by, because that is going to be the main tuple code that you look for when solving these problems, because you basically know nothing. Anyway, let's move on to the next problem. 5x plus 4y equals 22. Using the same method that we used for the first problem, we know that both 4y and 22 are divisible by 2. They're both even numbers. So therefore, 5x also has to be divisible by 2. And x, that means x has to be divisible by 2. And the first solution would be x equals 2. And that will result in y being 4y equals 12, and y would be 3. And then the next would be x equals 4, but then we find out that y would not be an integer in this equation, so that is not true, and we only have one solution for this problem, and that would be x equals 2 and y equals 3. Last equation, 30x plus 11y equals 350. So using the features of the one place, the units of 30x and 350 are both 0. So, because it's 30. So, therefore, 11y also has to be divisible by 10. And therefore, the first number that y can be is going to have to be 10. So, y equals 10. And if y is equal to 10, then we have 110. So, that would be 30x equals to 350 minus 110, 110. Be 240. So x equals to 8. And that would be our answer for this one. Yes? The question?
What if it's a really big number and you can't just try to find out the answer?
Excuse me?
What if you have a really large number and then you can't try to get the answer?
So, that's why, we don't just, try every single integer. We have to look for, the special features, which is, something that I talked about right now. So we have to look for what this number is divisible by and, what remainder it would be if when divided by another number. So it would, narrow down the range of the number. So for example, for this problem, we know that y equals 10 and x equals 8. That is the first solution. And the next thing that we try would not be y equals 11 and x equals and x equal whatever, because like that would be way too difficult. We know already that y has to be divisible by 10, so our next number would have to be y equal 20, and we're basically like skipping 10 like numbers already. So if it's an extremely big number, then when we solve out these problems, we'll probably have to skip by 100 and 1000, which also makes like problem solving a lot faster. And because it's like 不定方程式, it's like if it's too large, then it probably has no solution anyway. So we would also talk about another method later, and if you have any questions then you can continue asking me. Okay, thank you. So now let's move on to a practice problem. Okay, I'm gonna collect the answers now. So congratulations to everyone who were able to get the problem correct. So let's look at number 1. 19x plus 9y equals 100. So for these type of questions, because it feels like they are a little bit bigger compared to the exploration problem, you can do something to break them up. For example, 18x plus x plus 9y equals 100. And the reason that we break it up like this is because 18x is divisible by 9, so it would be easier. So now, basically these two numbers are both divisible by 9, and if we divide 100 by 9, then we have 99 with a remainder of 1. So therefore, there is only one x remaining. It means that when the entire equation is divided by 9, there would be a remainder of 1. So therefore, x would be congruent to 1 mod 9. So the first we try out would be x equals 1. And y would be 9 in this equation. And if we try out anything else in the future, you would find that there are no other solutions. So this is the solution for problem number 1. Second problem, 3x plus 5y equals 31. Using the same method that we used for the first problem, let's break it up. 3x plus 3y plus 2y equals 31. Therefore, we know that these are all divisible by 3, and that would leave 2y alone. And when 31 is divided by 3, it would have a remainder of 1, which would also apply to 2y. So 2y would be congruent to 1 mod 3. And that means that, firstly, we can try out y equals to 2. Y equals to 2. And in this case, x would be 7, I believe. Okay, and because it's just a mod 3, then our next tryout would be y equals 2 plus 3, which is 5. Y equals 5. And we find that this also works out, because when y is equal to 5, then that would be 25. And 31 minus 25 is 6, which means that 3x equals 6 and x equals to 2. And there are no further solutions, so these two would be our answer, because they both work out. And the last problem I'll write on the other side. Using the same method, 7x plus 14y plus 5y equals 213. So divided by 7, then we would have this gone, and this would have a remainder of 3. So 5y, it can go into 3 mod 7. So therefore, our first tryout would be y equal to 2. So y equals to 2. And in this case, x would be 213. 213 minus 38 equals to 175. And divided by 7, that would be 25. And the next would be y equal to 9. And in this case, x would be equal to 6. And we find that we can't solve any further, so these two are the answers for number 3. Are there any questions? If not, then let's take a 5-minute break. Okay, hi guys, I'm back. So, if I went back, please turn on your cameras and we can continue our lesson. So, sorry, turn on my Apple Pen. So, our next concept would be, next exploration would be quite similar, would just be a little bit more complicated. So, the problem asks us to find positive integer solution on the following equation, and we had to write at least 3 sets of solutions. So it's pretty much the same except our subtraction. So 3x would be let me rephrase. Firstly, if we rephrase the equation, we have 3x minus 7 equals 2y. So that means that when divided by 2, 3x has a remainder of 7. So 3x will be congruent to 7 mod 2. And we know that 3x is larger than or equal to 7 and x is larger than or equal to 3. So the solutions of this indefinite equations are, firstly, we can try out x equals 3. Is that true? 3 times 3 equals 9, and 9 has a remainder of 7 when divided by 2. Well, technically, if we simplify this, we have x is congruent to 1 mod 2. So that also applies to 3. and y would be equal to 1. And we can see that this equation has a really wide range because it's subtraction, so it doesn't really have a limit. So therefore, we can keep adding 2 plus 2 because it's mod 2. So therefore, we have x equals 5, and in this case, y would be equal to 4, and x equal to 7 plus 2 again, and y equals to 7. And there are so on. There are probably going to be infinite solutions, but the problem is that we need to write at least 3 sets of solutions, and these are 3 sets. Are there any questions for this problem? If not, then let's try out the next one. 10x minus 6y equals 46. So by simplifying this equation, we have 5x minus 3y equals 23. And we have 5x, so minus 23, it's going to be 3y. So when divided by 3, it's going to have a remainder of 23. So therefore, 5x is congruent to 23 mod 3. And by simplifying this, divided by 5, we have 2x is congruent to 2 mod 2. Divided by 3. So thus, x is congruent to 1 mod 3. And we also know that 5x is larger than or equal to 23 and x is larger than or equal to 5. So the first solution that we have that applies to x has a remainder of 1 when divided by 3 as x equals 7. So therefore y would be, I believe, 70 minus 6y equals 46. So 6y would be 24 and y would be 4. And let's continue. So for y, it would be add 5, and for x, it would be add 3, because it's mod 3. So therefore, x equals to 10, and y equals to 9, and x equals to 13, y equals to 14. So if we try out all of these solutions, we'll find that they are correct when double checked and plugged back into the equation. So these 3 are going to be our solutions for question number 2. Are there any questions? Not, then we can do our practice ones. But actually for the practice one, I'm also going to explain them directly because I believe they're also quite similar and we can solve them together. So firstly, 3x minus 2y equals 5. Using the same logic as we used before, 3x minus 5 is going to be equal to 2y. So 3x is congruent to 5 mod 2. And x would be congruent to 1 mod 2. Right. And 3x, we know that 3x is larger than or equal to 5 and x is larger than or equal to 2. So the first equation, the first possible number that x can be is going to be 3. X equals 3. Then in this case, x equal to 2 and y would be equal to 2. Then by adding 2, x would be 5. And plugging it back in, 15 minus 2y equals 5. So in this case, y would be 5. And we notice that y has been plussed by 3. So therefore, we will keep adding by x equals 7 and y equals 8. And we find that this solution works as well. So those are 3 sets of possible solutions. And again, this equation will most likely have infinite solutions, but those are 3. Next one, 15 minus 9y equals 33. So by simplifying this equation, we have 5x minus 3y equals 11. So 5x is going to be equal to 11. it's going to be congruent to 11 mod 3 using the same logic that we used before. And we know that 5x, again, is going to be larger than or equal to 11, and x is larger than or equal to 3. So therefore, the first solution that we have would be x equal to 4. And if we plug it back into the equation, we have 60 minus 9y equals 33. 9y equals 27, and y equals to 3. Next solution would be x would be 4 plus 3. So x would be 4 plus 3 equals 7. And in this case, by plugging it back in, we realize that y equals to 8. And you notice that every time y increases by 5, and using this pattern, we have x equals 10 and y equals to 13. So those are 3 of the solutions, and those are the answers for the problem. Are there any questions for this concept? If not, then we can finally move on to our last couple concepts, which are basically the same as before, but we are using word problems now. Okay. So first is a baseball league consists of 2 4-team divisions. That means there are 8 teams in total. And each team plays every other team in its division n times. So there are 4 teams in this one, 4 white teams, and 4 red teams. So basically, for each division on its own, there are n games. And for each versus each other, there are going to be n games. It is that each team plays every team in the other division m games. So that is going to be it. And it says that n is larger than 2m and m is larger than 4. So each team plays a 76 game schedule. How many games does the team play within its own division? Firstly, let's break this problem down. On one team, they would have to play 3 games against each other. 3 end games in their division, because there are 3 other teams, and because there are 4 teams in one division in total. So for one team, there are going to be 3 opponents for them in their division. So therefore, they are going to play 3 end games plus 4 M games, because there are going to be 4 opponents in another division. So therefore, 3n plus 4m equals to 76. And this is the equation that we are trying to solve. So now that we have the equation, it becomes a lot easier for us. Since it says that m is larger than 4, we can first try m equals 5. But this does not work, because as you can see, 56 is not divisible by 3. And we can try m equals to 6. But then we find out that that also doesn't work. So we need to use perhaps maybe a smarter method. So firstly, m equals 10. So firstly, if we find out that m is equal to 7, then this does work, because 4 times 7 equals 28. 76 minus 28 would be 48. And 48 is divisible by n. By 3, I mean. So 48 divided by 3 would be 16. And n equals 16, by m would be equal to 7. Anyway, so now that we know n equals to 16, there would be 3 times 16 games within its own division, as we already explained before. So that would be 48 games in total. So this is our first answer, but there are maybe possibly other answers as well. So let's look back at the problem. 3n plus 4m equals 76. We can break it down by saying 3n plus 3m plus m equal to 76. And when divided by 3, we have this has a remainder of 1. So n is congruent to 1 mod 3. And we can see that this actually works. But then our next solution would be, so basically since it's mod 3, then using the pattern that we figured out in the last exploration, the next possible solution for m would be 7 plus 3 equals 10. So m is equal to 10, and if we plug it in, then we find out that n would be equal to 36 divided by 3 equals 12. And this also seems to work, but remember that n is larger than 2m. So in this case, 12 is not larger than 2 times 10, so this does not work. And our only solution would be n equal to 16 and m equal to 7. So the final answer would be 3 times 16 equals 48. Any questions? If not, then let's try out the practice problem. So I'm gonna get the answers in, and it turns out that nobody was able to get this problem correct. So I'll actually explain it. It says that a grasshopper can jump from 5 paths to the right. So 1, 2, 3, 4, 5, or 3 paths to the left. What is the fewest number of jumps that she must make to reach the lily pad located 2,023 paths to the right of her starting point? So, if we turn this into an equation, let's say that every time she jumps to the right, it counts as x, and every time she jumps to the left, it counts as y. Then she would have 5x minus 3y equals 2,023. So, since it asks for the fewest number of jumps she must make, we need to make x plus y as small as possible. Then we should make x as small as possible. So, if we try it out, basically 2023 must be like some number divisible by 5 minus 3y. So the first number after 2023 that is divisible by 5 is 2025. But the difference from 2025 and 2023 are 2, which is not divisible by 3. Well, that doesn't work. So basically we need to look for something that is divisible by 3. So we know that the number divisible by 5 has a special feature. So let's list the next few numbers. We have 2030 and 2035. Right? So 2030 minus 2023 is 7. And this would be 12. We know that 12 is divisible by 3, so this one works. 2035 divided by 5 would be 400 plus 7 equals to 407. And x, so therefore x would be, 3x would be equal to 12, and x would be equal to 4. Okay, that means y, sorry. 3y and y equal to 4. So therefore, this is x and that is y. By adding them together, we have 407 plus 4 equals 411. So therefore, the answer is 411. Are there any questions? If not, then we can move on to our final concept. Final exploration, I mean. In a math test, there were 25 problems. 4 points would be earned for each correct answer, and 1 point would be lost for each incorrect answer. The points wouldn't change for a skipping problem. Jack and Jonathan obtained 61 points each, but Jack got more correct answers than Jonathan. How many problems did Jack not answer? So solution 1, basically, the maximum point is going to be 25 times 4 equals to 100. So let's say that they each got x problem incorrect. And they did y problems unanswered. So then that means that 25 times 4, which is 100, the maximum point, minus 4y, because 4 points would be earned for each correct answer, and if you don't answer the problem, you would get 0 points. And minus 5x, because there will be 1 point lost for each incorrect answer. And using the logic that we learned before with the other problem about getting an incorrect answer and correct answer, basically, if we had to take away, firstly, the 4 points that we already gave them credit for, as we assume that they got all of the problems right, and the 1 point that they lost for the incorrect answer. So therefore, 100 minus 4x minus 5x will be equal to 61. And therefore, that would get us 4y plus 5x equal to 39. And the solution of this indefinite equation, let's first look at it. 4y plus 4x plus x equals to 39, which implies that when divided by 4, x has a remainder of, when 39 is divided by 4, it has a remainder of 3. So x is also going to be congruent to 3 mod 4. So the first possible solution for x is going to be x equal to 3. And when we plug it in, we find out that 4x would be equal to 39 minus 15, which is 24. So y is equal to 6. And the next solution would be x equal to 7 and y equal to 1. So these are going to be the two solutions for our problem. And since there are exactly two solutions, then there are also two people in the problem, which are Jack and Johnson. It says that Jack got more correct answers than Johnson. So therefore, we can see that these mean that there are 8 questions gotten wrong or unanswered, and this means that there are 9 answers gotten wrong or unanswered. So for this solution, the person that had this result would have more correct answers. So therefore, this is Jack. It says that there are y problems unanswered. So therefore, Jack got 1 problem wrong, and therefore, the answer is 1. He did not answer 1 problem, but he got 7 problems wrong. Are there any questions? If not, then the next exploration problem is here. Let me change it actually. This problem was written wrong. This is supposed to be $24, not $25. Now let's look at the problem. Ralph went to the store and he bought 12 pairs of stock for a total of $24. Some of the stocks he bought cost $1 a pair, some of the stocks he bought cost $3 a pair, and some cost $4 a pair. If he bought at least 1 pair of each type, how many pairs of $1 stocks did Ralph buy? So let's say that there are X types of X pairs of $1 and Y pairs of $3. And there are D pairs of $4. So we have X plus Y plus 3 is equal to 12, and we have that X plus 3Y plus 4D is equal to 24. And we know that X, Y, and D, they are all greater than or equal to 1. So now if we can subtract the X, then we have 2Y plus 3D is equal to 12. So we know that Y and D are both larger than or equal to 1. So it follows that Y is a multiple of 3. 2Y. Is a multiple of 3, and 2y is a multiple of 6. So since 0, we have 0 is less than 2y is less than 12, we must have 2y equals 6. So when 2y is equal to 6, then 3d is also equal to 6, and we would have y equals 3 and d is equal to 2. And now we have 5. And plugging it back into this equation, we have 12 minus 3 minus 2 equals 7. So therefore, he bought 7 pairs of $1 stocks. And just in case, we can do some double checking. For example, we would have x equals 7 plus 3 times 3 plus 4 times 2 equal to 17 plus 7 equal to 24. Which is correct. So therefore, the answer is D, 7. Are there any questions? Now we can finally do our final question of the day. Practice 6. So this is the practice problem, but it's quite similar to the exploration problem that I just finished, so I can also solve it with everyone. Suppose James answered X questions. So a test consists of 15 multiple choice questions. 3 marks would be earned for each correct answer, 2 marks would be lost for each wrong answer, and 1 mark would be lost for no response. James gets 16 marks finally. How many questions does he get wrong? So, suppose that he answered X questions, X incorrect, and Y were unanswered. The maximum score would be 15 times 3. So 15 times 3 minus 5x, which is 3 plus 2, minus 4y, which is 3 plus 1, will be equal to 16, sorry. So therefore, we have 5x plus 4y equal to 45 minus 16 equal 29. And by solving this equation, we have 4x plus 4y plus x equals 29. And when divided by 4, we find that each side of this equation has a remainder of 1. So x is congruent to 1 mod 4. And therefore, the first solution that x can be would be 1. Let's try it out. X equals to 1. Then, in this case, y would be, let's say x equals to 1, then y would be 24 divided by 4 equal to 6. And there, we find that there's also another possible solution, that x is equal to 5, and y, in this case, would be equal to 1. There are no further solutions that we can solve, so we see that both of these solutions work, so they can be true answer. How many problems did he get wrong? He got either 1 problem or 5 problems incorrect. So therefore, the answer is 1 or 5. Any questions? If not, then we see that we still have 13 minutes, but it's like getting quite late because I started 30 minutes later than we usually do. So since there are no further content for today's class, that is going to be it. And I hope you guys have a nice sleep. I'll see you guys next Saturday. Thank you. Bye.